Hello everyone, we're going to be doing one section today all about trapezoids and kites. And the first part we're going to be talking about is trapezoids. So what we're going to be learning about the angles and sides and diagonals of a trapezoid will have certain properties. Now what a trapezoid is. A trapezoid, I have a picture of it here as well. A trapezoid is a quadrilateral, so four sides, with exactly one pair of parallel sides. Usually it's the top and bottom are going to be parallel. The parallel sides of a trapezoid are called bases. So the top and bottom ones are parallel, so those are the bases of the trapezoid. The non-parallel sides are going to be called the legs. So this side is a leg, this side is a leg. The two angles that share a base trapezoid are called base angles. So here and here are base angles, here is a base angle, here is a base angle. And a trapezoid has two pairs of base angles. So these are base angles for this side, and these are base angles for this side. Now an isosceles trapezoid are going to be a trapezoid with the legs being congruent. So if the legs are the same length, then the trapezoid is going to be an isosceles trapezoid. Same idea with an isosceles triangle where two legs are congruent and the base is different. Here we're just adding an extra side. We have a theorem that relates with isosceles trapezoids. It says if a quadrilateral is an isosceles trapezoid, I spelled isosceles wrong here, then each pair of base angles is congruent. So if TRAP, it's written weird, is an isosceles trapezoid with bases of RA and TP, then angle T is congruent to angle P, angle R is congruent to angle A. So if you have isosceles trapezoids, the base angles are going to be congruent. Not these ones, but the angles that share a common base are going to be congruent with each other. All right, we're going to go through two problems and then a couple more theorems. Okay, this problem says CDEF is an isosceles trapezoid. The measure of angle C is 65 degrees, and they want to know the measure of all the other three angles. Really, we only need to do one of these angles because of the fact that the base angles are going to be congruent to each other. So if we know that angle C is 65, we know that angle F is also going to be 65 because it's congruent. Now we only need to find angle D or angle E. I'm choosing to go with angle D for this problem, so we're setting up that angle C and D are going to be equal to 180 degrees because they're supplementary. Then I'm going to substitute in 65 for the measure of angle D, measure of angle C to solve for the measure of angle D. And then I subtract and I get that measure of angle D is 115. So, since each pair of base angles, not amphils, and fleas, I don't know. Since each pair of angles of an isosceles trapezoid is congruent, measure of angle C is equal to the measure of angle F, which is 65. So measure of angle D is equal to the measure of angle E, which is 115. So when we're doing these, you only really need to set up for one of them in order to solve for the rest of the three. So I'm going to have a problem for this trapezoid, this isosceles trapezoid here. Now we're going to go on to the next theorem about isosceles trapezoids, and that has to do with their diagonals. So if we have isosceles trapezoids, their diagonals are going to be congruent. So an isosceles trapezoid here, parallel sides, isosceles sides, that means that these diagonals are going to be congruent on either side. Next thing we're going to be doing with it are with trapezoids are mid-segments. Okay, so this next theorem is all about the mid-segment. If you remember what the mid-segment is with triangles, it's the point that connects to the midpoint of one of the legs and cuts it into two equal parts. So for trapezoids, it's the same thing. The midsegment is the segment that joins the midpoints of its legs, and they have two unique properties. So if a quadrilateral is a trapezoid, then the mid-segment is parallel to the bases, both bases, top and bottom. Also, the length of the mid-segment is half of the sum of the lengths of the bases. So if we take the top base and the bottom base and we add them together, the one in the middle is half of that. So here's a picture. There's no picture for this one. We have trapezoid TRAP with the midsegment MN. It means MN is parallel to TP and also parallel to RA. Then MN is going to be 1/2 of TP plus RA. And this is the part we're going to be working with mostly. So I have this one. QR is the midsegment of the trapezoid LMNP, and what is X? So 4x minus 10 is the top one, 8 is the bottom one, and then x plus 2 is the midpoint. So our formula, QR, the midpoint, the midsegment, is equal to 1/2 of LM plus PN. Plug in what we do know, x plus 2 equals 1/2 of 4x minus 10 plus 8. Then x plus 2 equals 1/2 of 4x minus 10. X plus 2 equals 2x minus 1. Add 1 over here, subtract the x over here. X is going to be equal to 3. Right now, I'm going to give you guys a question with a different trapezoid here. MN is the midsegment. PS and TR are the bases, and you're going to be asked to solve for this. All right, and now we're going to be working next with kites. Okay, so the last one we're going to do is a kite, which is a quadrilateral with 2 pairs of consecutive sides are congruent, but the opposite sides are congruent. So this means that this side and this side are going to be congruent to each other. This side and this side are going to be congruent to each other, but this side is not congruent to this. This side would not be congruent to that. You guys should know what a kite looks like. Those are the main things about it. So the angles, sides, and diagonals of a kite have certain properties. And the main one we're going to talk about are the diagonals for today. So if we have a quadrilateral and that quadrilateral is a kite, then its diagonals are going to be perpendicular to each other. So we have kite here, A, B, C, D. This side and this side are congruent to each other. BC and DC are congruent to each other. Then, I should have written this is perpendicular. AC and BD are going to be perpendicular. I missed that part. So we draw these diagonals from B to D and A to C, and these make right angles here. We're going to go through a proof of this. This proof is very similar to the one we went over in class before about the rhombuses having diagonals that are perpendicular. So we were given this kite, same as before, ABCD. AB and AD are congruent, BC and CB and CD are congruent, and we need to prove that AC is perpendicular to BD. So first off, we start off with our given kite ABCD, with AB is congruent to AD and CB congruent to CD. Reason given. A and C lie on the perpendicular bisector of BD because of the converse of the perpendicular bisector theorem. AC is the perpendicular bisector of BD because 2 points make a line, and then AC will be the perpendicular bisector. AC and BD will be perpendicular to each other. So just going back through this, we have that since AD and AB are going to be congruent, remember that if we have two lines that kind of equidistant to each other, so B is equidistant from A and D is equidistant from A, that means we're going to have a line going through this that is perpendicular to this line BD going through A. Now A will go, the line that goes through A will go all the way to C. So this here says that the converse of the perpendicular bisector theorem, saying that since these two are congruent, we're going to have a line that goes through A and that's perpendicular to BD because of these equidistant points here. Then, since A and C are going to be a line, since there's only one line that connects A to C, then AC has to be the perpendicular bisector of BD. All right, we're going to go through a question of this, and then we'll be done for the day. Okay, this question, to give us the kite DEFG, and they want to know what angles 1, 2, and 3 are, when they tell us that this angle up here is going to be 52 degrees. Now, we already know what angle 1 is because these diagonals are perpendicular, so angle 1 is going to be 90 degrees. And here we have a small triangle, so we could set these up so that 90 plus the measure of angle 2 equals 180. 142 plus the measure of angle 2 is 142 plus the measure of angle 2 is equal to 180, so the measure of angle 2 is going to be 38 degrees. Now, we have to figure out what angle 3 is. There's a couple ways we can do this. The way in the book says that since this triangle here, DEF, and this triangle here, DGF, are going to be congruent by SSS, because this side is congruent to the other side, and these sides are congruent. So all the corresponding sides are congruent. That means all the corresponding angles are going to be congruent. So 3 is going to be the same as GDF here. Now another way you could think of it as diagonals are going to come and bisect the opposite angles. So we have angle 3 and this angle here. So since they're being bisecting means they're going to be congruent, so angle 3 is going to be the same as this as well. It's another way you can think of it. I have one for here. This is angle 1, 2, and 3, and this over here is 36. So your question is to find these different angles. Okay, that is it for this lesson. We're going to do a review in class of all the different quadrilaterals and how they're kind of related to each other. And I'll leave a question at the end if you have anything you want to go over in class.